friends and students. Welcome back once again. Welcome to my channel. Okay, so today we are discussing a new topic. As you can see on your screen, we are discussing about LoRa communication and practical application of this particular communication. In this, we'll have a little knowledge, or rather we will have an overview, and also we will do a hands-on project, that is hands-on practical hardware project based on this particular topic, that is LoRa topic. In fact, we will do two projects. So in this video, we'll have only one project, or probably we will do one more project that will be in the next video. Now, what is LoRa? So we will just understand what is LoRa first. Okay. So you can see as a definition, LoRa stands for long range. It is type of a wireless communication technology. Please remember, wireless communication technology. Okay. So it is a wireless communication technology for low power, long range distance data transmission. Low power, that means it requires very less power and you can send data to long distance. Where it is used, what are the applications? IoT, remote sensors, smart cities, agricultures, etc., etc. There are so many other areas where you can do. Now you come down to the down below, you can see a little chart over here. That is, there are three categories: LAN, cellular, and low power WAN. Okay, so LAN, LAN can be there in the mobile, in home, or short range. It will be having a limited distance. Okay, cellular will have long range, high data rate, coverage, but the coverage, the best one is your LoRa. That is long range, long battery, and low cost, very, very low cost, right? So you should get little idea about this. So I'm going to do this thing. So in this particular topic, what we are going to discuss, what is the LoRa and what is LoRa WAN? You should understand both of them, because students and other people, they will confuse you. Sometimes you get confused. What is the difference, right? So please remember, LoRa WAN is a communication protocol, right? WAN, that is wide area network. It's a protocol. And LoRa is a modulation technique. Itself is a technique. Okay. So LoRa is a modulation technique. What type of the modulation we'll just discuss a little later. But LoRa WAN is a communication protocol. I told you that the key characteristics of low power LoRa is low power. Consumption is very, very less. You can run it with a battery. Second is, LoRa can be covered distance up to 10 to 15 kilometers, rural areas, where the distraction is very less. But in urban, it will be little lesser. Why? Because you have a complete jungle of concrete, and the other networks will also try to disturb this. So we have taken it to 3 to 5, this thing. Okay, right. Okay, scalability, that is LoRa network can support a large number of devices. This is very important. Please remember, the thousands of devices it can support. Okay, that means thousands of sensors can be supported to this particular LoRa network communication, right? Which is very important for your deployment in the cities and industrial setting. So anything which is related to your smart cities and industrial application or industrial this thing, you can use or you can go for LoRa communication. Got it? Okay. Now, this is about the LoRa work. Actually, how does a LoRa work? So please remember, now this is very important. As we know, it is a wireless radio frequency. Okay. Now, frequency range is first of all, before going into that, we should understand what is ISM band. Okay. ISM, the LoRa works on ISM band. ISM stands for industrial, civic, and medical. Industrial, scientific, and medical. That's why the name has been given ISM band. Okay, this was the band which was just left over and nobody used it. That's why this particular band has been given to or allotted to LoRa frequency. Okay, now basically there are three major frequency on which LoRa works. In EU, that is 868 megahertz, 915 megahertz in Asia, 433 megahertz transmission range, also in Asia in some countries. Now, moreover, in India, we use officially 868 megahertz bands channel. Okay. Now on the right hand side, you can just see on the below on the right hand side LoRa, that is, there is a chart that is comparing the bandwidth and the range. So it is comparison with the Wi-Fi, cellular, and LoRa. So range wise, it is beating all of them. Right? So already we have discussed about this. Now we'll go to the next slide and see. Now we'll discuss about the project. Okay. So what is the project like? environmental monitoring system using LoRa frequency. Okay, using LoRa. Okay, that is our project. Okay, how this goes to the abstract. The project involves designing a basic environmental monitoring system that uses LoRa for long distance data communication. It will monitor environment parameters like temperature, humidity, soil moisture, and other parameters. If you are using other parameters, you can just design it for yourself. Okay. So what is the main project objective or main goal? It can be the LoRa distance, how much distance it can be, it can be going, or IoT application, how you are going to use it for as an IoT application, whether it is better than the cellular or the Wi-Fi. This outcome you will get from this particular project. Okay. Now, what are the type of environmental monitoring? What do you monitor? Air quality, soil moisture. For farmers, it is very important. Water monitoring, whether it is polluted or not. Temperature and humidity is very, very common that all of us know. So we'll do a project based on temperature and humidity and vice versa communication. Now, okay, right. So hardware, what are the hardware required for our project? We require, these are the hardware. That is, we need a LoRa module, we need a microcontroller, we need sensor and some controllers and some power source. That's all. This is the only requirement we should have. Please remember, there are different type of modules. Only keep it in mind. We have to use a correct frequency module if it is India, or if it is some other country, then you have, according to their specification, you have to use it. Okay, right? So these are the hardware. These are the steps you have to follow. Set up the hardware, connecting the LoRa modules and all. Right? Write and upload codes. Right? We will discuss about that code also. I will share all the codes and everything with you. Right? Okay, don't you worry about it. So step 3, configure the gateway forward and set the data IoT platform, like visualize data on a dashboard. We are in the visualization. We are using a display here. Okay, you can see here, this is our circuit. This is the master one. That is, we are using one master server. That is, we are also making a network. So you will understand networking also. So there is a display. We have used ESP32 LoRa module, 2 switches for controlling the other side, whatever the equipment you want. Suppose there is a motor, it's a farm-based project or it's an industry-based project, then you can control some devices from the master. Okay, right. Second is, these are the slaves. We are using 2 slaves. Please remember, I will show you when we go to the lab. We will use 2 slaves. So 2 slaves, what is the temperature in that particular where the slave 1 is there and slave is there, and are we able to control the slave 1 LED or device there? Let it be anything. Okay, so these things will do it practically with the help of this. So let's go to our lab and start our looking into our project. All right, friends and students, we are into our lab now. So we are studying, or rather we have made this project. So let's name this project first. Okay, what names we can suggest for this project? My suggestion would be IoT controlled farm with temperature and humidity values. Like, I will just give you an example. There are two farms. Okay, farm number 1 and farm number 2. So you want, by sitting in the home, you can control the motors of both the farms, as well as you can check what is the soil moisture or the temperature and humidity at farm number 1 and farm number 2. So how you will like this thing? So I will just explain you about this first. So this is your master. This part will be there in your home, and these 2 are the slaves. Okay, slave 1 and slave 2. That is farm 1 and farm 2. Okay, so I will just explain you about the master. So master has what parts, important parts in it. So this is your ESP32 module, okay? With Wi-Fi also it is there. So you can use it for further this thing. You can just make a small LAN surrounding to the Wi-Fi, and you can circulate the information, okay? So second important part, the most important part rather, is this, okay? What is this? This is your LoRa module, okay? LoRa module, I have used RA02, the module number, which is made by AI Thinker. Okay, the frequency, just for testing purpose, I'm using 410 to 522 megahertz. That is ISM band. Okay, right. So what else I have used in this? 2 switches to control farm number 1 and farm number 2. So, and the display also. You can see here on the display, or you can see so many things. I will just tilt it and I will just show it to you. Okay, so I will just try to show it to you by going a little near. So you can see on one slave 1, some display is there, that is temperature and humidity. And slave 2, you have temperature and humidity, as well as LED 1 and LED 2. It is written off. Okay, right? Off. That is LED 1 is off, LED 1 is here, and LED 2 is there. Okay, so it is written off. Right. Please remember, this is very important part of it. That is antenna. Please remember, without antenna, it will not work. Antenna has to be perfect. Otherwise, it will not work. Secondly, the connection from Lora to your microcontroller, Lora to microcontroller is also very, very important. The clocks connections, the reset connection, the MISO and MOSI, TX and RX connections, these are very important. Second, very, very important thing, Lora, maximum of the Loras, they work with 3.3 volts DC, right? Here, 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 and here. All the Loras, they work with 3.3 volt DC, okay? All of them have antenna. See, this master, this slave has this type of antenna. I just wanted to show you. I've used different type of antennas. So this is one antenna for on another slave. This is antenna. All the three of them have antennas. Please remember. Okay. Right. Okay. This is what are these slave to side? What are these two? These are temperature, DST11, temperature and humidity modules. Then LoRa module. There is an indicator on both the side. That is slave 1 and slave 2, which can be controlled from this place. But I've just kept it nearby. Please remember, you can keep it very long distance. But what you have to remember, you have to remember this. The antenna should be proper, and the bigger the antenna, the area coverage will be more. So you have to control this. So what I will do is just see, I will just press one button here, and what happens on the other side, you please just watch. This LED is on. That let's assume that this is slave 1. Now I'm just switched on it. I will switch it off. At the same time, you are getting LED 1 on and off written on this thing also. I will do it once again. Please watch it. I will put the second one. You can see it came and went away. Again, I'm pressing it on. Like here, you can see here it is written LED on. That means my motor is on, my any other equipment I can control, that is on. And let's switch it off. It is off. It is written off. See, this will send signal to this. I will just explain you. How does it work? Okay. So how does it work? First, the master sends a message to both of them. That is slaves, slave number 1 and 2, it will send message. Okay. Right. After sending message, there will be how it will be. There is a separate address for this slave and that slave. So it will detect. This microcontroller will see, check whether the message is for him or for his colleague. That is the other guy. Right. If it is for him, he will process it and he will reverse it back that I'm ready, or this is my temperature and humidity, and I have to receive the signal. Suppose I have pressed a button on the master. So this will come on. That is, it is receiving the message. The slave, because it is given for slave 1. Slave 2 will not work. Please remember, slave 2 will not work, but slave will work. So it is written LED 1 on. Okay. So I am just switching it off again. Off. Right. It is written LED 2 is off. And all this temperature and humidity, like temperature is 30.80, humidity is 42%, right? So everything will be here, and you can make this project very easily. I have already given, of course, I will give you the complete details about the project and the schematic diagram. You can do it little. It comes in the category of mini as well as major project. With this, you can come up with a very good ideas. Please remember, masters I have given through a battery. This is very important. 9-volt battery, 5-volt regulator. I have connected this. Okay. This is the master. So slaves, what I did, I can connect the regulator here and I can give connection. But since I have given connection from my computer, that is the 5-volt I have given, I have taken it from my computer. So that you have to remember it. Antenna is very important part. Module is very important part. What frequency of module you are using, and the coding part. Of course, I will share the coding part also with you. So these are the codes for the Lora master. So I just wanted to show it to you. What are the important? These files are important for us. That is all these files. That is libraries are important for us. So you have to, because we are using SSD 1306. That is as a display GFX library. We need wire and Lora H library. This is important for us. And serial library. Next it will be pins. You have to define the pins 1312. That is button pins. You have to design, and so you have to define the screen width. Okay, the 3 pins which you have to indicate. That is, I told you, that is a reset, SS, and the DIO 0 pins. So you have to give that. And one more thing you have to give, that is local address. So if you have to give local address to this, because it is said here that a slave 1 has different address and slave 2 you have to give different address, 0203. Likewise, you have to give, and this is your local address to 01. Okay, local address to this master. So you have to be careful, because for slave 1 you have to give 02, and slave 2 you have to give 03. You will not give the same address that is slave 1 and all. Rest of you can do it, nothing to worry. It is the tested codes, and you can do it. If you find any difficulty, you can tell me, you can write to me. I will certainly try to help you out. Okay. So already it has been done by somebody else. I did it by myself on a PCB. That's why I just wanted to show it to you. So this is master code. I will just to give me a moment. I will show you the other code also. In codes, please remember, it will have the same code that the DST pin. You have to tell here LED. You have to indicate here. Same reset SS and DIO pins. You have to same. You have to here. Please see here. It is they are highlighting as the this is important for you. That is, and this is your master address, and this is your address. So slave 1 and slave 2 will have different address, and reset time and Lora frequency, what frequency you are using, that you have to indicate, or you have to tell it here, then only it starts working. So rest of the things I will be sharing same code for your slave 1 as well as slave 2. Only addresses you have to change. Okay. So in this code, everything has been given. You have to follow the codes and all. Everything I will be sharing with you. So please try to do it. It's a good project. It's a new project. And please remember this particular thing. I hope you like this project. Very important, very interesting project. And please remember, this is very latest project. You people can do it. And you can just see here how it is working. I will just try to press it on, and you can just make it out. Okay. Okay. So you can see here it is on. All right. Okay. I will just switch it off. Switch off. Okay. So likewise, you can do it very easy. I made it on a general purpose PCB. Okay. The size of the PCB, you can do it. You can OLED display. I've used it. You can use a bigger display also. You have to identify, and you can give, and this takes very less power. This is only works on 3.3 volts that you have to see. So this is master. I will show you the slave also from a little more closer. Okay. You can just make it out. This is slave. Okay. So slave 1, and this is slave 2. This is the antenna for slave 1. This is the antenna for slave 2. Okay. This is slave 2. Okay. Same. All the three I have used ESP32 microcontrollers. So I hope you like this. If you like it, please write for me. If you like it, please subscribe to my channel. I will be sharing good videos. Next video will also be based on Lora. Please remember, in there we will do home automation, IoT based, Lora based home automation. There I will show you. Might be we will use some other microcontroller. So this is 1 masters, 2 slaves, how it is working, the network, how it is working, that I have tried to show you. I hope you understand. Please subscribe to my channel, and please like. If you want to give any comments, if you have any questions, you are free to ask to me, and I will be welcome. I will be glad to give you the answers, and I will definitely share the codes and everything with you. Thank you.